So the next way to find compound probability that we're going to talk about is a probability tree. Remember that I have a compound probability when I have multiple events, and I'm looking for specific outcomes in each event. I need both of those things to occur. I can use a probability tree whenever you want. It can really work in any situation whenever you're doing probabilities. Sometimes it makes more sense than others to use it, but you can use it whenever you want. It's the most helpful, though, when there are more than two events, because you can't use an area model for that. Remember that area models, I can only use them for two events. So if you have something that's compound probability and there's more than two events, I would use a probability tree. Remember again, probability is desired outcomes over total possible outcomes. Let's check it out. So again, you can use it whenever you want. So I'll show you an example, the same one that we did with the area model, which was I'm going to spin this spinner twice. What's the probability that I get a red and a blue? And what's the probability that I get a red and then a blue? So remember last time, we set up spin 1, spin 2, we brought them all down. Here's all your possibilities, there's 16. For red and a blue, it's 2 out of 16, which is 1 out of 8. And for a red and then a blue, it's 1 out of 16. Let's see what that looks like as a probability tree. So what we're going to do is say event 1, so here's spin 1. And then we're going to say, what are the possibilities? There's red, yellow, blue, and green. So to make it a tree, we're going to do this. You'll see why it's called a tree in a moment. And then we'll say spin 2. This might get a little messy. What are the possibilities for spin 2? Well, that is red, yellow, blue, and green. So if I spin a red first, there are 4 possibilities that happen next. If I spin a yellow first, there's 4 possibilities that happen next. If I spin a blue first, there's 4 possibilities that could happen next. I'm going to not draw the next ones for green because as you can see I'm running out of space. But you'll see at the end we're going to have all the possibilities. Here is red, red. Here is red, yellow. You just follow the tree. So you start from the beginning, and this is a list of all possibilities at the end. Red, blue, red, green. Same here, I can follow to yellow, red, yellow, yellow, and so on. So this final thing will be a list of all your possibilities that comes from the tree. So if it asks you what's the probability of red, a red and a blue, you will go to, let's use a different color. You could go here, red and a blue, there's one. And there's also this one, blue, red. This will be blue, red down here. So here's 2. Again, there will be 4, 4, 4, and 4, which is 16. So that will be 2 out of 16 for probability of blue and a red, which we know. We found that out with the area model. Again, if it wanted a red and then a blue, it would only be this one. So that would be 1 out of 16. So it works in the same way. But where it is more useful is in a situation where there are more than 2 events. In this case, there will be 3. If I flip this coin 3 times, what's the probability I get at least 2 heads, a tails, a heads, and then a tails, or all tails? So what we're going to do is make a probability tree. So we'll have flip 1, which is either a heads or a tails. Then we'll have flip 2, which would be, if I flip a heads first, I either have a heads or a tails. If I flip a tails first, I either have a heads or a tails. And then I'll have flip 3. If I flip a heads and then a heads, it can either be a heads or a tails. Heads or tails. For each of these, heads or tails, heads or tails. So then again, we're going to list all the possibilities. We go here, heads, 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 tails, heads, tails, heads. So what we did was come up here. This one's heads, heads, heads. This one's heads, heads, tails. Now we're done with that, so heads, tails, heads. And then we'll have heads, tails, tails, and so on. So you'll notice in this list that none of these repeat. These are all different because these are all the possible outcomes. It wouldn't make sense for them to repeat because you've already listed that as a possible outcome. So these happen in order. This would be the first, this would be the second, and this would be the third. That's because that's how we made our tree. And if we want to find probabilities, we're going to use this as all of our possible outcomes. So we'll say, what's the probability of at least 2 heads? That means everything that has at least 2 heads counts as a desired outcome. This has at least 2 heads. 1, 2, 3, 4. There's 4. Out of 1, 2, 3, 4, 5, 6, 7, 8. 4 out of 8. It's actually a 1/2 chance that I have at least 2 heads. What's the probability of getting a tails on the first, heads on the second, and a tails on the third? Well, there's only one that does that. Let's find it. Tails, heads, tails. Here it is. That's 1 out of the 8. Probability of tails, then heads, and then tails is 1 out of 8. What's the probability of all tails? Well, that's just this one on the bottom. That would be 1 out of 8 as well. So here's all your possible. Just go through, find the ones that you want. How many meet the criteria that you want? That's your desired. And then how many possible. So in conclusion, I have a compound probability when I have multiple events. I'm looking for specific outcomes in each event, and I need both things to occur. I can find that probability by creating a probability tree, which I can use whenever I want, but it is the most helpful when I have more than 2 events. Because if I have 2 events, usually it's easier to just make an area model. So of course, we just list out the events, and then we make a nice little tree. At the end, we can follow each branch to list out the possible outcomes. And I'll have a list here at the end of all possible outcomes if I follow each branch. And that is finding compound probability with a probability tree.